our channel ClassFly community. So today we will be dealing with the topic EMF equation of the alternator. So whenever we do the EMF equation of the alternator, it is basically in the armature winding. So we have to assume some things to solve this equation. So the first thing which we need to assume is Zp with the number of the conductors of coil side in series per phase. This means that the coil will have some number of conductors, and always remember that one uh, conductor will be equal to 2 turns, where T is the number of coils or turns per phase. Okay, so you can also note that one turn or coil has 2 ends. So the main thing which you need to remember is one conductor will have 2 turns. And the next thing which we have to assume that phi be the flux per pole, and this Weber is your unit, and in short we write as WB. P is the number of poles in the rotor. So in the rotor part there are various number of poles, so we will represent it by P. And N is your the speed of the rotor in revolution per minute, that is your unit. And F is your frequency and its unit is hertz. And T, as I already told, that it will be the number of coils, or you can say the turns per phase. So there are three factors. First is your distribution factor, which is represented at Kd. Kp is your pitch factor, which is also represented by Kc, and Kf is your form factor, whose equation, or you can say whose value is 1.11. So first of all, we will need to find the flux for one conductor. So when the conductor cuts the flux, it is number of poles into your flux, and it is unit is Weber. And in one revolution of the conductor, so to complete one revolution in second, it will be 60 by number of poles. So we can say that P5 is equal to P5 and also dt to 60 by n seconds. So that means number of poles into flux and 60 by n, that is the one revolution of the rotor. So next it says that the induced EMF per conductor will be d5 by dt. So we can say 5p by 60 by n. So in altogether we can say it is pi np by 60. And in place of n, which is a synchronous speed, which we already know, we will place the value 120 f by p, and this f is a frequency and this p is a number of poles. So when we place this value in this place, we get that 60 cuts 120 by 2 and pp gets cut. So we are left over with 2f5 volt. And so this is for the conductor, for that means for the equation for one conductor. So for many conductors, what we will do, because we know that one conductor is equal to 2 turns, for many conductors it will be 2f5z, that means the equation EMF equation, and here it is volt because the EMF equation unit is volts. So it will be 2f5 and into z. So we will get that when we put z equal to 2t, we get 4f5 t volts. And we also know that whenever we find equation, we need the RMS value, and we can find the RMS value by, because we know that form factor is the ratio of the RMS value, that is the root mean square, by the average value. So we need to find the RMS value. So we know that form factor is 1.11 and we know that the average value is 4f5t, right? So we get 4.44f5t volt. So this is an induced EMF for the RMS value. But if we have the distribution factor, that means if a winding is distributed, then we need to add the factor Kd, that is a distribution factor. If there is also the pitch factor, we have to write Kc or Kp. So the RMS factor, or you can say the RMS value of the induced EMF when distribution factor as well as the pitch factor is there, then the equation will be Kd Kc 4.445 Tf. And from this equation you can simply understand it is similar to the EMF equation of the transformer. So I hope you understood the EMF equation of the alternator. So till then, be happy and have a great day.
Now is the code time. Part of my life is to save life. I hope all of you understood the lecture of today, and thank you for watching.
Wow, that's impressive. You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.